Not long to go until this by Mr. Steinman. High School of Dundee. Can't wait to see it. It's going to be amazing.
It's time for Maths with Mr. Thomas.
Woo! Here we go. Chapter number 5. Lesson number 6. We're moving on to scattergraphs and the equation of a best fit line. So, what's scattergraphs all about? Well, scattergraphs are used to display two sets of variables, two sets of data, to see if there is a link between them. That link is known as a correlation. So, if you end up graphing your two variables and you see that as one value increases, so does the other, then you have what is known as a positive correlation. So, in other words, if your scattergraphs looks something like this. An example I'm giving is the outside temperature versus ice creams sold. Obviously, as the temperature increases, well, the number of ice creams that a shop will sell will also increase. There's more demand when the temperature is warm. So as the temperature is increasing, the ice creams sold is also increasing. So it is known as a positive correlation. And we can see that as one increases, so does the other. If one value, though, increases and the other one decreases, it's not a positive correlation, it's a negative correlation. So, an example, something against something else, what could be a negative correlation? Ooh, that's a good one. The one I've got here is, once again, the temperature, but I'm putting that against the number of coats that are sold. As the temperature increases, well, a shop will sell less coats. If you take something like Primark, however you say it, if the temperature outside increases, well, they're not going to sell so many coats because people will be out in their shorts and t-shirts. Whereas if the temperature is lower, it's getting down towards freezing, they will sell more coats. People are going to be buying them. So you can see that as one value increases, the other is decreasing. And these points are going down the way. This one here, they were going up the way. Why is it called a scattergraph? Because the points are scattered! Brilliant. And sometimes when you end up plotting points in a scattergraph, you end up with something that looks just like this. It's just an absolute mess of points. And if you do end up with that, then you can see the values aren't increasing, they're not heading up the way, not heading down the way, they are really just scattered about in no order at all. So you could say for that there is no correlation, there is no link between this x variable and the y variable. An example would be your age against the number of siblings, against the number of brothers and sisters you have. Just because I'm older than you does not automatically mean I have more brothers and sisters. Because you guys are younger than me, it doesn't mean that you have less brothers and sisters. It makes no sense whatsoever. You could have somebody that's in their 90s, it doesn't mean that they automatically have loads more brothers and sisters than all of us. Makes no sense. They might be an only child. So your age against the number of siblings, that would just be all scattered about. There's no link between them whatsoever. So scattergraphs, they're used to compare two sets of variables, and the correlation is the link between them. It can be a positive correlation, it can be a negative correlation, or there might be no correlation, no link whatsoever. Example 1, let's move on to actually plotting points on a scattergraph and commenting on the correlation. So we've got the rainfall in millimeters just at the top, and we've got the number of umbrellas sold at the bottom. We are wanting to put that into our scattergraph, so we'll have our x and our y axes. I've put rainfall just at the bottom. The biggest number here is 6, so I'm just going up to 7. I'm just putting 7 down there. And for the umbrellas sold, well, the highest number is 47, so I'm just going up in 5s and taking that up to 50. What we need to do is we're needing to plot each of these points. In order to plot the points, we're just needing to put a dot wherever this number would be. So when the rainfall is 3, so we're going to go along to 3 at the bottom, 1, 2, 3, and we're wanting to go up to 1, so we would go up to 1. Well, I know 5 is going to be up here, so 1 will be just about there. So 3 millimeters rainfall and just 1 umbrella sold. We now want to go to the 2, so when there was 2 millimeters rainfall, well, it was 10 umbrellas sold. So we're going along to 2, and then up to 10. Well, that's 5 there, and then we're going up to 10, so 10 is there. We now have 4 millimeters of rainfall, so go along to 4 millimeters of rainfall, and we're going up to 25 umbrellas sold. Oof, you must be loaded, umbrella man. So 4, and we're going up 5, 10, 15, 20, 25, so that's just a point round about there. What you want to do is you want to keep going along there. You've got the number of millimeters of rainfall, and we've got the number of umbrellas sold. If you do that and put in all the other points, here is one I have prepared earlier. And you can see that all the points are plotted on the scatter graph. Thinking back to the correlation, remember you could have a positive correlation where both values are increasing. You could have a negative correlation where one value increases while the other decreases, or you could have no correlation at all. The points are completely scattered about. Well, you can see that for this one, that both values are increasing. We can see here they're quite low, but as the rainfall increases, well, the height of the points also increases. So the rainfall is increasing and the height that the points are at also increases. So you can see that both values are increasing. And that makes sense because if you think about it, if there is more rain outside, then there will be more umbrellas sold. So what you can say for this, the comment that you would write down would be, the graph shows that there is a positive correlation between the number of umbrellas sold and the amount of rainfall. And that is all you would have to do for that question. Something that you're often asked to do when you are plotting points on a scatter graph is, if there is a correlation, whether it be positive or negative, is to draw in a best fit line. The best fit lines look something like this. They are lines that go in the direction of the points. They are roughly in the middle of the points with the same number of points on both sides, roughly, and they should be in the direction of the points. So you can see for this one that the points are heading up in this direction. So your best fit line should also head up in that direction, as it does. You can see for this one here, the points are heading down here. As the temperature is increasing, the number of coats sold is decreasing. So these points are heading down the way, so the best fit line will also head down the way. As I said, it should be roughly in the middle of the points with roughly the same number of points on both sides. Make sure you don't have it drawn like this, where all the points are below it instead of above. Make sure equally you don't have it like that. Make sure you're not starting at 0, 0. You do not need to start at 0, 0. What quite a lot of people do is they end up having it looking like that. But if you extend the lines and then you extend the points, well, the points, if they continue in that pattern there, you can see that the best fit line and then these points, they're not matching up. That makes no sense. You do not have to start at 0, 0. Make sure that you ignore that. Use your ruler. I would always put the ruler on its side, turn the page on its side as well once you've plotted the points, and then have the ruler look down the edge of it, roughly the number of the same points on each side, and you're going in the direction of the points. So if you continue the best fit line, if we continue that up there, and you continue the points, well, they should be matching up. Yeah, so it should look something like that. Equally, when you're coming down the way as well, again, it's definitely not going to start from 0, 0. Some nutcases end up having it looking like this, and that'd be totally wrong because the points are coming down in this direction. Your best fit line's not going to go up there. The best fit line has to follow the points in the direction of the points with roughly the same number on both sides. And again, use your ruler, just lay that on, put it on its side, and then have a look at each side, check it's roughly the same number of points, and check you're following that direction. You should end up with something like that. Let's try an example then, using the best fit line. So example 2, this scatter graph shows the value and age of 10 Land Rovers. Vroom, vroom, vroom. Draw in the best fit line and use it to estimate part A, the value of a 4-year-old car, B, the age of a car when it's worth £50,000, C, the value of a 7-year-old car, D, the value of a new car, and E, the age of a car when it drops to half its original value. So the first thing you want to do is you want to draw in the best fit line. Once again, make sure that your best fit line does not start at 0, 0. You're definitely not going to have it looking something like that because you can see the points are heading down this way. So if you did that, you would be a nutcase. Do not do that. You can see the points are heading down. If you try and do this with a mouse, the points are heading down in this direction, so you should draw in something that looks like that, maybe even lowering that line ever so slightly. looking something like that. So you can see there's roughly the same number of points on both sides, and you're roughly in the direction of the points. That is one that I drew earlier. So if we're using that best fit line in the direction of the points, roughly the same number of points on both sides, use that to answer these questions. So our answers. Part A. Do you want to try this with me? See how many you get right out of 5. Go on, it'll be fun. So, for A, go on. Alina, the value of a 4-year-old car. How old would a 4-year-old car be? Brilliant, you are perfectly right. It would be £40,000. And the reason is, if I just get the mouse to show this, if you go along to 4 years, that is what we're wanting. Go straight up to your best fit line. Once you hit the best fit line, go straight across to work out its value. And we hit bang on that £40,000. Make sure it is £1,000. You're right, don't just say £40. That'd be the cheapest Land Rover in the world. So that would be the price of a 4-year-old car. For part B, the age of a car when it's worth £50,000. What do you think that will be, Ellie? Ooh, you think 2 years? You're perfectly right. Well done, Ellie. High five. The age of a car when it's worth £50,000 would be 2 years old, because if we start at that £50,000, there's £50,000, go straight along to our best fit line. That is what we're using to make these predictions. Then go straight down. We hit 2, so we are at 2 years, which means the value of the car at £50,000 would be roughly 2 years old. Woo! Let's try another one. Have you got 2 right so far? Oh, well done. You're a good. High five you. C, the value of a 7-year-old car. So find 7. Well done. You know how you do this. Go up to your best fit line. Bump. There's your best fit line. You go straight along after you hit that. And what do you end up at? Brilliant. Yeah, you end up with about that 25,000. I'm putting down £25,000 here. Well done. Equally, if you said 24,000, that would be accepted as well. It's just roughly, what would it be at? Just make sure you don't say 20 or 30. Just try and be as accurate as you can with this. So I'm going with £25,000. For D, the value of a new car. Ooh, how do you do that? That is a very good question, Mohammed. Let's have a look. Well, Titus, help out Mohammed.
Well, the value of a new car can be found because the age of the car will be at 0. It's brand new, it's not been used.
You're perfectly right, Titus. Well done.
Oh, that makes sense.
It does indeed, Mohammed, yes. So the age of the car will be 0. So if we go up to our best fit line, bam, there's a best fit line, and we're already at 0. So if we go along, well, we're not going along, we're already at the start, and we're at £60,000. So it means then the value of the car is £60,000. Yeah. And finally, for E, the age of a car when it drops to half its original value. Ooh, how do we do that? Well, what's half the original value going to be, William?
30,000.
It will be 30,000. Good, there is 30,000. And if we go along to our best fit line, there's best fit line, and if we go straight down, bump, we end up at the number 6, which means then the age of the car when it drops to half its original value will be 6 years old. Yeah. How did you do out of 5? Did you get 5 out of 5? Ah, you're so good. You are the best. Simply the best. Often in National 5, what you have to do is come up with the equation of the best fit line. Sometimes you'll be asked to plot the points, draw in a best fit line, and then come up with the equation. Sometimes it will be done for you. The points will be there, the best fit line will be drawn, and it will say what is the equation. In order to do that, you need to think back to chapter 3, straight line, when you came up with the equation of a straight line. Remember, to come up with the equation of a straight line, you need the gradient, you need a point on the line, and then you can find the equation. So let's try an example with that. Example 3, a farmer records the weight of his sheep. The scattergraph shows the relationship between the age, A months, and the weight, W kilograms, of the sheep. A best fit line is drawn. equals. There's our best fit line there in red, and you can see it goes in the direction of the points, roughly the same number of points on both sides, and it's looking lovely. Point D represents a 2-month-old sheep which weighs 33 kilograms, and point E represents a 14-month-old sheep which weighs 129 kilograms. Part A, find the equation of the best fit line in terms of A and W, and Part B, use the equation to estimate the weight of a 1-year-old sheep. So, our best fit line has been drawn, our points have been given, and in order to come up with the equation of the best fit line, we'll think gradient point equation. We need to know the gradient. And to work out the gradient, well, y2 take y1 over x2 take x1. Stop! Sorry, Brian, what's wrong?
We don't know any points.
We don't know any points? We do know points, Brian. Look at it. It tells us here point D represents a 2-month-old sheep. And it weighs 33 kilograms, which means that for point D, we came along to 2 and we went up to 33, which means that if we write that as a point, it will be 2, 33.
Oh, so it does. Does that mean then that point E will be 1,429?
It does indeed, Brian. Yes.
Oh, my apologies.
No problem, Brian. With our points, we have an x value and a y value. Again, x and y. So, if we're working out the gradient with y2 take y1 over x2 take x1, we'll have 129 take away 33 over 14 take away 2. If we work that out, it's going to end up at 96 over 12, which gives us 8, which means there is a gradient of 8. To work out the y-intercept, you can either use y take b equals m bracket x minus a, or the way I do it here is I am going to substitute in the gradient and the point into y equals mx plus c. So, doing that, take one of the points, doesn't matter which point you are using. I'd probably use the one with smaller numbers, try to avoid any negatives as well. So the y value is 33, so I'd have 33 equals, m is the gradient, which was 8, so it'd be 8 times x, and x was 2. So 33 would be 8 times 2 plus c. C is just staying as it is, and we're wanting to work it out. So that means that 33 equals 16 add c, and 16 add what gives you 33? Well, you can find it by working it out that way, or you can take 16 off both sides. Either way, you end up with 17! Well done, which means the y-intercept will be 17. So what we've got so far is the gradient to be 8 and the y-intercept to be 17. Moving over the page, we have this information so far, and we're asked for the equation of a best fit line. For the equation of the best fit line, you need to know the gradient and you need to know the y-intercept. So our gradient is 8, so we can replace m with 8, and our y-intercept is 17, so we can replace c with 17. Are you happy with that for our final answer? No! Why not? Perfect! Make sure you go back and read the question. It's asking us for the equation to be in terms of a and w, so it's not wanting x and y, it wants a and w. A for age in months and w for weight in kilograms. So we need to swap the x and the y with a and w, but which is which? Is it going to be a equals 8w add 17, or will it be w equals 8a add 17?
Oh, we don't know.
So how do we find out? Well, what I would always do is look at the y-axis. So you know this is your x-axis, so that'll be the x-axis, and this up here will be the y-axis. Our y-axis, well, we're not calling it y, we're calling it w. Yes, we can replace the y with w. And our x-axis, we're not calling it the x-axis, we're calling it a. So instead of 8x, we'd have 8a plus 17. So that will be our equation in terms of a and w.
Oh, that's so clever.
You know? Yeah. Part B, use the equation to estimate the weight of a 1-year-old sheep. We just came up with this equation, w equals 8a plus 17. Now we need to estimate the weight of that sheep. We can substitute. You are perfectly right. Yes, we've got the 1-year-old sheep.
Oh, so do you put in the 1 instead of a, because the age is 1, so it's 8 times 1 at 17. Oh, I know what you do!
No, you don't! That is a common mistake. Or do you put in 12? Why do you put in 12? Jackson, why?
That's because the age is in months.
You're perfectly right, yes. It tells you here the age is in months. So if it's 1 year old, well, how many months is that? 12. Brilliant. So the first thing we have to do is think, well, 1 year is 12 months. So the age in months will be 12. So it's going to be 8 times 12. Add 17. And if you work that out, well, we know 8 times 12 is 96. Add on 17 gives us 113, which means then, using our equation, we have found the weight of the sheep to be around 113 kilograms.
Yeah!
That is it for Scattergraphs. That is pretty much everything that you need to know for Scattergraphs. Try some of these questions in the TJ National 5 book. And again, look at past papers if you want them there. There are a few questions in those or any of the other National 5 books. In TJ, it's page 179 to 182. Best of luck plotting points on Scattergraphs, drawing in best fit lines, coming up with equations, and using equations to make further estimates.
Yeah! So much fun!
I know. Enjoy! See you later. Bye!
Mr. Steinman, are you ready?